Now in this problem, x of n is given to be n into sine pi by 2n into u of minus n. Now we have from the property of differentiation in z domain, n into x of n forms z transform pair with minus z into d by dz of x of z. So this is the property called differentiation in z domain. Now for which there should be n and x of n, and there should be the x of z, what you get is for z transform of x of n. So here n is already present, so this as a whole forms x of n. Okay, so I can take it as x1 of n, right? So the z transform of this as a whole must be minus z into d by dz of, see here, when n into x of n, it is d by dz of x of z, so minus z into here x1 of n, so it is x1 of z, right? So if this thing is clear to you, you can solve this problem easily. So what I want, so the z transform of x of n is x of z, it is equal to minus z into d by dz of x1 of z. So what is x1 of z? I need to calculate. It is summation n is equal to minus infinity to infinity x1 of n into z power minus n. Now what is x1 of n? It is sine pi by 2n u of minus n. Now what is u of minus n? See, we have u of n to be a waveform which starts from 0 and reaches infinity, right? Now what is u of minus n? U of minus n is the reflection of u of n. So u of n started from 0 and it went till infinity, so u of minus n starts from minus infinity and it reaches 0, right, with an amplitude of 1 everywhere. So this is 1, 2, minus 1, minus 2, minus 3, minus 4. This is 1, 2, 3, 4, 5, 6 and so on. So this might the limit here would change from n is equal to minus infinity to 0. So minus infinity to 0, and in that range, what is my x1 of n? It is sine pi by 2n. What is u of minus n in that range? It is amplitude is 1, so I need not worry about it. So z power minus n. Now as usual, you have equation for sine, and I'll change the limit to infinity. Infinity I'll take it up because I have standard formula for summation 0 to infinity. So summation n is equal to 0 till minus infinity. Sine I can write it as e power j pi by 2n minus e power minus j pi by 2n divided by 2j into z power minus n. Right. So if I want to, or rather I'll take 1 by 2j out, what I will be getting is summation n is equal to 0 to minus infinity e power j pi by 2 z inverse power n, this term as well as this taken together, minus this. So summation n is equal to 0 to minus infinity e power minus j pi by 2 z power minus 1 power n. So this is what I am getting here, right? Now I want the upper limit to be infinity, so what do? Substitute n is equal to minus n. So I'll write it here, put n is equal to minus n. So what I'll be getting is 1 by 2j into summation n is equal to 0 to infinity, because if I put n is equal to minus n also, it is 0 only. So it is n is equal to 0 to infinity, and what I will be getting here is e power j pi by 2 z inverse, and n is replaced by minus n, right? And the second summation is summation n is equal to 0 to infinity, minus infinity will become infinity, e power minus j pi by 2 z inverse power minus n again. Now rearranging the terms again, 1 by 2j summation n is equal to 0 to infinity. I'll take minus inside, so I'll be getting e power minus j pi by 2 z power n plus minus summation n is equal to 0 to infinity e power j pi by 2 z power n. What I just did is I took the minus sign inside. So this is the equation which I'll be getting. So I'll rub this off. So I had to write this x of z is equal to minus z into d by dz of x1 of z, right? This was my equation. So this is the x1 of z. Now at this moment I can go for checking the ROC. So this summation has to be less than 1 for this summation, this term has to be less than 1 for this summation to converge. So it is magnitude of e power minus j pi by 2 z must be less than 1. Here also magnitude of e power j pi by 2 z must be less than 1. So magnitude of e power minus j pi by 2, as I have solved in the previous problems, magnitude of e power j theta is always 1. So I will be getting magnitude of z less than 1, and here also I will be getting magnitude of z less than 1. So ROC is magnitude of z less than 1. Okay. So that is the ROC. Now for x1 of z will become 1 by 2j into it is 1 by 1 minus e power minus j pi by 2 z minus 1 by 1 minus e power j pi by 2 z. It is summation n is equal to 0 to infinity alpha power n. So it is 1 by 1 minus alpha. So after this, if I since I have here so this is my x1 of z. So I need to substitute in this equation to get x of z. So I will simplify this further. 1 by 2j, if I take the common denominator, or I need not take the common denominator, I can simplify here itself. So it is 1 by 2j into 1 by 1 minus e power minus j pi by 2. Where shall I write it? Write it here. E power minus j pi by 2. This is simple. Cos pi by 2 minus j sin pi by 2. So cos pi by 2 is 0 minus j into sin pi by 2 is 1. So I will be getting minus j. So here I will be getting 1 minus j. It is minus j, remember. So it is 1 plus j into z minus 1 by 1 minus e power j pi by 2 is cos pi by 2 plus j sin pi by 2. So cos pi by 2 is 0, j sin pi by 2 is 1, sin pi by 2 is 1, so I will be getting j. So 1 minus j into z. Now if I take the common denominator, 1 by 2j into, it is 1 plus jz into 1 minus jz. So here I will be getting 1 minus jz minus 1 minus jz. So 1 gets cancelled here. I will get minus 2jz divided by 2j into, what I get here is 1 a plus b into a minus b. It is 1 square minus b square. B square is j square z square. J square is again minus 1. So I will be getting plus. So this 2j gets cancelled. So the value of x1 of z is minus z divided by 1 plus z square. This is the value of, that means this is z transform of sin pi by 2 n u of minus n. please be sure of what you're doing. The z transform of this function we have calculated, it is minus z into 1 plus z square. Now we want to find the z transform of x of n, that is x of z. So x of z is equal to minus z into d by dz of x1 of z. It is minus z divided by 1 plus z square. So it is minus z. This differentiation, minus I can take it out here, I will be getting plus. So this differentiation is u by v rule. So 1 by z square whole square into 1 plus z square into differentiation of z, that is 1, minus z into differentiation of denominator, that is 2z. So I will be getting z into 1 plus z square minus 2z square divided by 1 plus z square whole square. Now it is z into 1 minus z square. So it is z into 1 minus z square divided by 1 plus z square whole square. This is my final z transform of x of n, that is equal to n into sine pi by 2n u of minus n. So don't worry that we had so many steps in solving this problem, but understand the fundamental as to how to solve a problem when you have multiplication by a RAM, that is n into some function. So this function's z transform you calculate and you substitute in the differentiation in z domain equation. So if you have x of n is equal to n into some function, it is minus z into d by dz of z transform of this function, and then differentiate. So that will be our final z transform. Now in this problem you have been given with convolution of two sequences, that is half power n u of n and 1 by 3 power n u of n. Now we have proved a property. If x of n convolution y of n, if you take the z transform of it, it will become x of z into y of z. What is the meaning of this is, if you have convolution in time domain, it will get converted into multiplication in z domain. So I need to find x of z. So it will be z transform of half power n u of n into z transform of 1 by 3 power n u of n. Now what is z transform of alpha power n u of n? Alpha power n u of n is 1 by 1 minus alpha z inverse. So in place of alpha I have 1 by 2, so it will be 1 by 1 minus half z inverse into 1 by 1 minus 1 by 3 z inverse. So if you want, you can multiply and keep, or else this is the final answer. So I will be getting 1 minus 1 by 3 z inverse minus 1 by 2 z inverse plus 1 by 6 z power minus 2. So this will be 1 by 1 minus 5 by 6 z inverse plus 1 by 6 z power minus 2. So this is my x of z. The question looks complicated, but the answer is pretty simple if you know the property of convolution. It is convolution in time domain is equal to multiplication in z domain. Now in this problem, x of n is given to be sine pi by 4n minus pi by 2 into u of n minus 2. So this can be simplified as x of n is equal to sine, minus of minus is plus, so pi by 2 plus pi by 4n u of n minus 2. Now remember, sine of pi by 2 plus theta is cos theta, right? Because of ASTC rule, ASTC, all are positive, sine is positive. So pi by 2 plus theta means it comes in the second quadrant, so sine is positive there. But since pi by 2 into odd multiple, that is 1, so I will be getting cos. So here I'll be getting cos pi by 4 n u of n minus 2. So x of n is this. Now if I want to find x of z, u of n minus 2. Now we need to know what is u of n minus 2. By now you should be knowing u of n minus 2 is shifting u of n right by 2. So that means my u of n minus 2 will start from 2 and go till infinity, 3, 4, 5 and so on. So here the summation n is equal to 2 till infinity cos, or I'll write the equation first, normal generalized equation. So it is summation n is equal to minus infinity to infinity x of n z power minus n. So summation would change from minus 2 to infinity. What is x of n in that range? It is cos pi by 4 n. What is u of n minus 2? Amplitude is 1. So it is z power minus n. So summation n is equal to 2 to infinity. Cos I can write it as e power j pi by 4 plus e power minus j pi by 4 divided by 2 into z power minus n. Now how do I make this lower limit to be 0? I'll substitute n minus 2 as m. So my, sorry, here I have missed out on n. Okay, so my limit would change to m is equal to 0, because when n is equal to 2, m is equal to 0 and infinity. Here I'll be getting, I'll take 1 by 2 out, 1 by 2. Here I am combining these two, so it will be e power j pi by 4 z inverse power n it was, right? Or I'll simplify here, 1 by 2 summation n is equal to 2 to infinity e to the power j pi by 4 z inverse power n, and plus summation n is equal to 2 to infinity e power minus j pi by 4 z inverse power n again. I've just split this summation into two parts. So here I will be getting m is equal to 0, power n will be m plus 2, so it will be m plus 2 here and this side as well. So here summation m is equal to 0 to infinity e power minus j pi by 4 z inverse power m plus 2. So this is what I'll be getting, and I need to simplify this further, so I'll rub this off. Now here e power j pi by 4 z inverse power 2 is a constant. Here also it is a constant, so I'll be taking 1 by 2 is anyway it is out, so I'll be taking e power j pi by 4 z inverse square as a constant. So I'll be getting summation m is equal to 0 to infinity e power j pi by 4 z inverse power m, right? And plus here e power minus j pi by 4 z inverse power 2 is again a constant, and I'll be getting m is equal to 0 to infinity e power minus j pi by 4 z inverse power m. So this will be half into e power j pi by 4 power 2, so it will be e power j pi by 2 because pi by 4 into 2, and I'll be getting z power minus 2. This will be 1 by 1 minus z inverse, so 1 by 1 minus e power j pi by 4 z inverse. Here again e power minus j pi by 2 z power minus 2 divided by 1 by 1 minus e power minus j pi by 4 z inverse, because this is constant, this is alpha power m, alpha power n, so 1 by 1 minus alpha. This 2 I have multiplied inside, so pi by 4 will become pi by 2. Now e power j pi by 2 is cos pi by 2 plus j sin pi by 2, so it will be j z power minus 2 divided by j e power j pi by 4. I'll keep it as it is, e power j pi by 4 z inverse, and here it is minus j, because e power minus j pi by 2 is minus j, z power minus 2 divided by 1 minus e power minus j pi by 4 z power minus 1. So you can simplify it further, but the final answer, if you simplify it further, you will get the simplified version, or else you can keep it at this moment. So this is my Z transform of the given problem. Now this is one more tricky problem wherein you have n square into 1 by 3 power n u of n minus 2. Now we know that the Z transform of n into x of n is minus z into d by dz of x of z. So you have n into n, that means 2 times n, so that is why you have n square. That means I need to use this differentiation in z domain property twice on this. Now remember, if n into x of n, I need to differentiate that. So I have n into, I can take this as x1 of n, right? x1 of n. Now I need to find, so x of z, so this can be written as x of n is equal to n into 1 by 3 power n u of n minus 2. That means first you use n into x of n, x1 of n, and the answer is minus z into d by dz of z transform of this. Then again you have n, so it is minus z into d by dz of the z transform of that, the one which we already get. So this can be done in many ways. So I'll do this using the property. Now x of n, here I can x1 of n is 1 by 3 power n u of n minus 2. So I can write this as 1 by 3 power n minus 2 u of n minus 2. So this is time shift property. So what is time shift property? X of n minus n naught is z power minus n naught into x of z. That means if there is a shift everywhere, then there will be exponential multiplier, I mean z to the power the shifted version. So since 1 by 3 power n was made 1 by 3 power n minus 2, I need to multiply here by 1 by 3 power 2, because 1 by 3 power 2 into 1 by 3 power minus 2 gets cancelled and you get 1 by 3 power n. So this is 1 by 9 into 1 by 3 power n minus 2 into u of n minus 2. Now what is the z transform of 1 by 3 power n u of n? It is 1 by 1 minus 1 by 3 z inverse. It is alpha power n u of n form. So it is 1 by 1 minus 1 by 3 z inverse. Now what is, if it is shifted by n minus 2 u of n minus 2, that shift should come as a power of z. So z power minus 2 divided by 1 minus 1 by 3 z power minus 1. Are you guys clear here? Because this shift will become the power of z. So the shift here became the power of z. So here the z transform of this would be, that means x1 of z is 1 by 9 z power minus 2 divided by 1 minus 1 by 3 z inverse. So what we have got here is the z transform of this function, right? So I'll convert this in terms of z so that differentiation becomes easy. x1 of z is, I'll multiply the numerator by z square and denominator by also z square. So I'll be getting 1 by 9 here 1 z square minus 1 by 3 z. So this is what I'll be getting the answer as. So if I multiply by 3 here, if I take the common denominator 3 and 1 by 3, so I'll be getting 1 by 3 divided by 3z square minus z. So this is the answer which I'll be getting when I solve here. So this is x of z what I get. Now by using n into x of n, so for the first n, so this is x1 of z, so this is x1 of z. So for the first n, the z transform is minus z into d by dz of 1 by 3 or 1 by 3 by 3z square minus z, right? So this would be minus z, this is minus 1 by 3z square minus z whole square into differentiation of there is 1 by 3 here, this term. So differentiation of this is 6z minus 6z minus 1. So if I simplify this, it will be plus, so 1 by 3 6z square minus z divided by 3z square minus z whole square. So this is the z transform of n into x of n. That means we have found the z transform of this as 1 by 3 divided by 3z square minus z, and by using n into x of n we have found this much. Now, and there is one more n, so I need to take that into account as well. So it will be final x of z will be minus z into d by dz of n into x of n. So I need to find z transform of this. Z transform, what is the z transform of this? It is this function, because I have used n into x of n. So it is 1 by 3 6z square minus z divided by 3z square minus z whole square. So 1 by 3 I can take it out, so minus z by 3, use u by v rule. So it is 3z square minus z square power 2, so it is power 4 into 3z square minus z whole square into differentiation of this, it is 12z minus 1, then again minus 6z square minus z into differentiation of this, this is differentiation of this function denominator, that is 2 into 3z square minus z into 6z minus 1. I think you are familiar with u by v differentiation. So this, the denominator square, in the numerator I will get that same denominator into differentiation of the numerator 12z minus 1 minus numerator into differentiation of the denominator, it is square, so 2 into this minus 6z minus 1. So if you simplify this further, you will be getting the answer as the final answer, which I will be writing down here. It is 6z cube, rather 4z cube minus 7 by 3z square plus 4 by 9z minus 1 by 27 divided by z into z minus 1 by 3 power 4. So this is x of z. So if possible, you simplify or else you can keep it at this juncture. You can solve, simplify this for a short duration, as in to get a smaller answer and keep it. So this is the final answer which I had got it from the solved answer. So this is the final answer of this problem. But the whole understanding here is you need to know how to apply the frequency differentiation property. So n into x of n, if you have, you need to find the z transform of x of n, that is x of z. Then I will be using the property minus z into d by dz of x of z. So these are the types of the problems which are very important. Now the last problem under this section, x of n is equal to cos omega naught n u of n. Now since you have u of n, it is obvious that it is a right sided sequence, so ROC is outside the outermost pole. Now to find x of z, that is summation n is equal to minus infinity to infinity x of n z power minus n. Now since you have u of n, the summation would result from n is equal to 0 to infinity. What is x of n? It is cos omega naught n z power minus n, because u of n value is 1. So I'll be getting n is equal to 0 to infinity. Cos is e power j omega naught n plus e power minus j omega naught n divided by 2 into z power minus n. So I'll be getting summation n is equal to 0 to infinity. I'll take half out. So here I will be getting e power j omega naught z power minus 1 power n plus summation n is equal to 0 to infinity e power minus j omega naught z power minus 1 power n. What I just did was I took half out, e power j omega naught z power minus 1 whole power n I have written, and similarly in this case. So it is half into 1 by 1 minus e power j omega naught z inverse plus 1 by 1 minus e power minus j omega naught z inverse. So if I simplify this further, if I take the common denominator, I will be getting half into 1 minus e power j omega naught z inverse into 1 minus e power minus j omega naught z inverse, and in the numerator I will be getting 1 minus e power j omega naught z inverse, minus j omega naught z inverse minus or plus 1 minus e power j omega naught z inverse. Right? This is the factor which I'll be getting. So if I simplify this further, half into 1 plus 1, it is 2, plus or minus z inverse into e power j omega naught plus e power minus j omega naught divided by, this is 1 minus e power minus j omega naught z inverse minus e power j omega naught z inverse, and what I'll be getting is e power j omega naught into e power minus j omega naught is 0, e power 0, that is 1, plus z power minus 2. So plus z power minus 2. Now if I'll still simplify this, 2 minus z inverse, here e power j omega naught plus e power minus j omega naught divided by 2 if I do, and in order to nullify it I'll multiply by 2 here, so it will become 2 z inverse. Here I'll be getting 1 minus z inverse into e power j omega naught plus e power minus j omega naught plus z power minus 2. Again I'll divide by 2 and multiply by 2 here. So what I'll be getting is half into 2 minus 2 z inverse, this function is cos omega naught divided by 1 minus 2 z inverse cos omega naught plus z power minus 2. So my x of z final answer is 2. If I take it out, it will get cancelled here, so I will be getting 1 minus z inverse cos omega naught divided by 1 minus 2 z inverse cos omega naught plus z power minus 2. So this is the final answer of the z transform of cos omega naught and u of n. So if you are asked to find z transform of cos pi by 4 and u of n, in place of omega naught you substitute pi by 4 directly, or it is better not to mug up this final answer, rather you derive it on your own. So x of n is equal to cos omega naught and u of n, you have got this value. X of n is equal to sin omega naught and u of n also you can find out simply by making this minus here and divide it by 2j and make the appropriate changes, right? So there can be one more type, alpha power n cos omega naught n and u of n. So how do you do this is find the z transform of this, that is this function, and you have the property alpha power n into x of n is x of z by alpha. So wherever you have z, replace it by z by alpha. So if you have alpha power n cos omega naught n u of n, so find z transform of this, and wherever you have alpha, replace it wherever you have z, you replace it by z by alpha. So I have covered almost all the types of problems, different varieties of the problems which come under finding the z transform of a discrete time signal. If you have any queries, you can comment in the section below. Thank you for watching. Hope this will be helpful for you.